Yes.
That's good.
I mean,
It's
a nice number of points. Your quiz was very few points. I think I made your quiz like 28 points, so your test will be nice. All right. So, I need to talk a little bit about naming triangles. What would the name of this triangle be? Triangle what? ABC? That would be a good name. Okay, this is triangle ABC, and angle C is the right angle. So A and B are our acute angles. Now, we can name the sides of triangles in two ways. You could name this side AB, couldn't you? Side AB. And if we were talking about the measure of AB, then we wouldn't put the little bar over it, because that would just mean the measure of AB. There's another way we can name sides. We name sides by what they're across from. Like this side is across from angle C. So if I use a lowercase c, we could call this side C. This side is across from angle B. So I could call that side B. And this side is across from angle A, so we could call it side A. So sometimes they're referred to in your textbooks. If you check out stuff online, they may say side A, and it might not be marked. Well, you should know that side A is across from angle A. All right? So that's just a little bit of housekeeping right there to make sure we all understand. Now, let's take a look at something interesting, and you should have started thinking about this when you did your homework. Let's look at sine of angle A. Sine of angle A. What is that? It would be, in this case, it would be A over C. Good. A over C. What about cosine of angle A? Cosine would be B over C. Okay, let's stick with cosine for a second. What is cosine of switch angles? B. That ratio would be A over C, wouldn't it? And now we did cosine of B, so now let's do sine of B. What would sine of B?
B over C.
B over C. Do you guys see that these two are equal to the same thing? And when we have two things that are equal to the same thing, can we set them equal to one another? Substitution. So we could say sine of A must equal cosine of B. And cosine of A is equal to sine of B. Well, now let's take a look at A and B. Let's say I called angle A theta. Would angle B, could I name it 90 minus theta?
Yes.
Why?
Because it's like a big degree.
What do these two acute angles have to add up to? 90, so that the sum of the three angles is 180. So whatever angle A is, angle B is its complement, right? So let's look at this. Sine of any angle is the same as cosine of its complement. Cosine of any angle is equal to the sine of its complement. So if I started out a statement here and I said sine of 10 degrees is the same as cosine of what? 80. Because 10 and 80 make 90. Well, let's actually check it. Sometimes we just believe Miss Willoughby, and sometimes we test it. Let's test it. Punch in on your calculator. Let's evaluate the sine of 10 degrees. Now, first time we use our calculators. Whenever you use calculators, there's several different ways to measure angles. This year, we're doing everything in degrees. When we tackle the trig unit again, we'll look at it in degrees and in radians. So please make sure that your calculator is in degree mode. And the way we do that is we press mode.
Good save.
Did you like that?
Hey, that was awesome.
I was falling, so I blocked with my foot.
And make sure degree is highlighted. And it should be on everybody's calculator because that's the only thing I'm working with right now in my classes. All right, so punch in sine. Sine is 2 above the 7. Sine of 10. What do you get?
1.73648.
Okay. All right, so approximately 0.174. Now let's do cosine of 80. Cosine is 2 above the 8. Do you get the same thing? Yes. They are exactly the same. So every digit I can see on my calculator matches up perfectly. They are equivalent.
Oh my.
Okay? Are we good?
Exactly.
So, if I said cosine of 25, that is the same as what?
Sine of...
Sine of
90 minus 25.
90 minus 25, which is
65.
65.
I'm not really good with math.
That would work out well, except you're in math class. All right. So the big idea here is when we look at sine or cosine of any angle, sine of an angle is equal to cosine of its complement. Cosine of an angle is equal to the sine of its complement. That's the big idea on this. Okay. Today we're going to take another little baby step into helping us use right triangle trig in the real world to solve a real world problem. Okay? So we got to build the foundation so that we can understand how to solve these problems. So, Kyle, this is our last little baby step before we jump into it tomorrow. So these are notes if you haven't started taking them. Here is a right triangle. I have labeled it triangle ABC, and I gave you side C is 10 units, and angle A is 25 degrees. That is enough information to find every missing side and every missing angle. That is enough. So write this down, and then we're going to set these up together. I'm going to show you how to think through them. Okay, the first thing we're going to do is we're going to try to find side A. So this is what we're going to try to find, A. Now, to find this, what we first do is we notice it's a right triangle, so we're going to try to use right triangle trig. It's not a special right triangle, so we have to use right triangle trig. So we're going to label this A with respect to the given angle is which side? Opposite, adjacent, or hypotenuse? Opposite. B is the adjacent, and the side we were given, 10, is the hypotenuse. So I always look at what is given, and I look at what they're asking for. Look at what's given. Look at what they're asking for. Which trig ratio involves opposite and hypotenuse? Let's look at sine. So sine of angle A. Well, I don't have to write angle A because they actually gave me the degree measure today. So sine of 25 degrees is equal to the opposite, which is A, over the hypotenuse, which is 10. Now we just solve for A. What do we do to solve for A? Just multiply by 10. So to solve for A, what we punch into our calculator is 10 times sine of 25 degrees type of multiple choice test, like if you had an end of course test that covered this, they may leave the answer just like this. The SAT may leave the answer just like this. So you don't have to have a calculator to do it. But what is 10 times the sine of 25?
4.226182617.
Let's just do the hundredths place. That's good enough. 4.227, 226. What was it?
226.
Okay, so it would round to 3. Okay. So A is approximately 4.23. Now, you may be tempted at this point, so you go, ooh, now I know 2 of the 3 sides, why don't I just use Pythagorean theorem? Who can tell me why that might not be the best idea?
Because it's not at 36.
Because the decimal. We just rounded right here, didn't we? So if we round here and then we square it, what are we doing with our error? We're compounding it. We're making it a little bit more off. So we don't really want to use this if we don't have to. Sometimes you've got to, but we don't have to. Because now to find the other one, to find B, I can go back to the angle I was given, the side I want, and the side I was given. So now I'm looking at this same problem, but from a different perspective. I want side B. And side B is the adjacent side. The side I was given is the hypotenuse. So which trig ratio will I be using? Cosine. So cosine of 25 degrees is equal to adjacent over hypotenuse. All right, finish that one up for me.
I'll figure out the answer. Wait.
You did.
Did you get approximately 9.06?
Yes.
Okay, any questions?
No, pretty good.
Not too hard, huh? All right, let's take a look at another one. So this one's not ABC. This is triangle XYZ. So X would be down here, wouldn't it? Side Y would be right here, and side Z would be here. Does that make sense?
No.
Okay. Here's angle X. Side X will be across from angle X. Side Z is across from angle Z. And side Y is across from angle Y. All right, so they told us that X is 4, so we know this is 4. We know the measure of angle X is 32 degrees, so let's put it in there, 32 degrees. And we want to try to find Z. So we're given this, we want that. All right, let's take a look. This is which side right here?
Opposite.
Opposite. This is which side? Adjacent. SOHCAHTOA. SOHCAHTOA. Which trig ratio involves opposite and adjacent?
Toa.
Tangent. And TOA is how we remember that. Opposite over adjacent. So tangent of 32 degrees is equal to the opposite over the adjacent. Okay, so now this time the variable's in the denominator. Still not difficult. We just have to get it out of the denominator. So to lift this out of the denominator, we'll multiply both sides by z. And da-dun, it's out of the denominator. So now we have z times tangent of 32 degrees is equal to 4. So now what will we do to solve for z? Divide by tangent of 32.
This makes so much more sense than it did last year.
Great.
I literally didn't get it at all
Yeah.
last year.
Yeah, me neither. I didn't do it.
Okay, that was just rude.
Yeah.
All right. It's okay. It's okay. Did you get 6.40?
Yes.
Yes.
After putting the calculator.
Sorry, I'm stupid. I am.
No, you're not. But you are disruptive at times.
Yeah, and I'm
That's right. Okay, I have a few for you to try. So they're all with regards to this triangle. I didn't label the sides A, B, and C, but you can. So you have 3 different problems. So I'm changing up the angles. The angles aren't going to be the same in each problem. So you might want to draw 3 different sketches and label it specifically for the information you were given here. Okay? So I want you to try these. Now, if you're struggling with this, I'm going to be walking the room. You just slow me down. Let me help you.
Okay. What now?
She's saying find AJ. Miss Willoughby, she reads side C, but I don't understand. Are the sides supposed to be labeled? Because it says find A, find C, find B.
I didn't label. Where would A be?
That's a good question.
Side A is going to be across from angle A, so it's right here.
Oh, yeah.
Side
Duh.
B is across.
See, I told you I'm stupid.
right here.
It's fun making fun of yourself.
Okay, so that's a good point. I did not label the sides, but let's remember that side A would be across from angle A, so here it is. Side B is across from angle B, so there it is. And side C is across from angle C. So that might be helpful.
So design.
Is that how you would solve it? You get A opposite, you would have
Since it's opposite of my partners, try to find A. And so you try to find A, and you already have my partners, so you have to do one that includes them. So side is so opposite of our partners. You try to find A, opposite of our partners. So you put A, 32, and so you do 32, minus the side of 1. But if it was opposite side, no, this is internet. Adjacent over my partners.
which side is that?
Cosine.
It's sine 20.
So it'd be 28 divided by cosine of 41.
Is that what you're doing?
I just need to yours. I'm not looking at that.
Okay, well that's probably not right. Actually, that might be right.
Yeah.
Right now. 37.100.
No, I
No,
think
37.
I'm not fine. It gives me angle A is 23.
Alright, that's the last one. C is 49.
But it says that finding
Find A. Find little A, right?
C.
Wait, no,
Hold on.
No, 1. It's find
No,
little
but
A.
yeah, but
C
it
is
says that C is
32.
32.
Okay, so now I have 32. So if you want to find this, how do you find
You have your C wrong. You
opposite
have your C wrong.
32?
No, so C right there would be the hypotenuse. C is your hypotenuse.
And 1.
That's right.
Last one is 14.
Alright, then I'll
That's right.
What do you want?
Oh wait.
So then you would put.
This one is. Which one is it? So, or to? Cosine? So you're gonna do cosine of 21. So it's 28 divided by cosine.
You know what A is.
So if it's the top, you're gonna divide. And then if you're gonna, if it's on the bottom, you're gonna multiply.
For which one? I got 37.10.
You're kind of like 80. You have like a
I know. I have one.
No, that's a calic right there. See? I have calic right back here, something like that. And so it's going to be a cut my hair straight from that. We do whatever. Except my dad. Or something on a buzz cut.
I'm gonna
Does
start.
he have a
My
buzz
mom
cut?
cuts my hair.
He likes
From the zoo.
slightly short.
From the zoo.
Yeah, I give it 2.
I get a 2 too.
Really?
When I get my hair cut. Although I grow my hair right now.
Two on the side.
Just a little bit.
I don't know how long I can grow it out. Just until I feel like I need to get a haircut.
You should get like dreadlocks.
That's a long way.
What, dreadlocks?
Okay, those of you that need to continue working, that's fine, but I'm going to go ahead and put up the answers for those of you that are ready for them. So look at those answers, see if they make sense to you. If you have any questions, let me know.
This little bit, this unit makes sense.
Awesome. I'm excited.
Please tell me we're not doing anything else. Oh, we have another week. Yeah. Oh, yeah, I get another week. Am I doing this now?
Is it, are you choosing the wrong tree function, or are you choosing the wrong tree?
I can be a
And then on the test.
I think I have ADD, but my mom would be a
STEM.
tell her every time. I say that first.
You done.
Whole life.
You done.
I think
I have OCD.
I can't pay attention.
I have OCD.
Yes, you can.
All right.
OCD.
Okay, so if you hadn't finished the third one, you might want to take a look at the notes that I post later on and make sure you got that one right. There's a few more examples I'd like to go over, though, before the end of class. So we're going to look at our same triangles, but this time from a different way. This time we're going to try to find the angles, not the sides. And it's not very hard.
Get real.
So this one, in number 1, I want you to try to find theta. Well, just like every time, what we have to do is look at the triangle, look at what we're given, and decide which trig ratio this might be. So with respect to this angle theta here, 3 is which side? The opposite. 7 is which side? The hypotenuse. So this is just like last night's homework, wasn't it? You set up a ratio. So just like last night, you set up sine of theta equals 3 over 7.
Is that the answer?
That's what you did for homework, didn't you? Now, it's one step further. That's all we have to do. Now, in math, we're always looking for a way to solve. And to solve things, we usually have to find things that undo each other. And you started back in elementary school. Like we learned how to undo addition. What did we use? Subtraction. We learned how to undo multiplication. What did we use? Division. We used inverse operations. Things that undo each other. So, Salter, on this, we're going to use an inverse. To solve for theta, when I have sine, I'm going to use the inverse of sine. And the inverse of sine is represented like this. The inverse of sine is the sine to the little -1. Now, if you're looking at your regular calculator, you just push if you're looking at the calculators we use in class, you just push the sine button twice. On some calculators, the inverse of sine is just above sine, so you'd have to hit second in sine. Those of you that are going to do your homework tonight with a calculator on your cell phone, it's a little more difficult. It's not quite as easy to use as the calculators we have here in class. So the first thing you have to do to find sine and cosine on your calculator on your phone is do what?
Turn it sideways.
Turn it sideways. That's where you get all that extra stuff. Okay, so you should see sine, cosine, tangent on here. But these are the ones we would push if you knew the angle measure. Like if I wanted to know sine of 20, you kind of have to enter it differently. You type in 20, whoops, and then hit sine.
No, not cos. No, sine.
I know.
And so I got the same thing we did a few minutes ago, 0.34. All right, now, if I had a ratio such as this one, 3/7, and I wanted to use the inverse, on your phones there's a little second button, and when you press the second button, you get a lot of new choices over here.
There's a second.
And one of them's the inverse of sine.
Where's the
So we have to do,
William,
first we have to enter
Was it 19?
3 divided by 7.
Okay.
So first we would enter 3 divided by 7, and then we would do that second sign button.
It said
Okay? Now,
You get 25 points.
No, it said
Yeah, mine says
Mine says
Out.
9.27.
did you do 3 divided by 7, enter, and then push the second sign button? Alright, I'll be honest with you. The phones are so tricky on how you have to enter things. I don't even like them.
Yeah.
They irritate me.
25.37693352515231.
Alright, you should have gotten, what'd you get, 25.37?
6933.
38, okay.
515231.
No, Ryan. You have to hit second down.
Gosh, you're so illiterate.
I got that on my calculator.
Okay, so I don't really care if you're using the phones. I really like the calculators a lot better because you punch it in just the way it looks here. You do inverse sine of 3/7. Inverse sine can also be called arc sine. Depends on the book. Arc sine is the inverse sine. Okay, so let's look at number 2. Now that we know how to make our calculator do it, and we know how to make our phone do it, let's see if we can actually do a problem. So this time I called it x instead of theta. Who cares? So this is the angle that we're looking for. So 4 is which side?
Adjacent.
Adjacent. And 13 is hypotenuse. So which trig ratio involves adjacent and hypotenuse? Cosine. So cosine of x is equal to 4/13. So to solve, we would do inverse cosine of 4/13. And let's just do this one to the nearest degree. To the nearest degree,
72.
Been there, done that, right?
we get 72 degrees. Yes.
Like, cost-wise.
Yes, and we're not using that. You won't do it for a long time. We'll talk about it later. I don't. Yes, there is. Yes, there's a lot of them. Okay. All right, you try. You try this one. I gave you the picture a little bit differently, but you can still do it.
And we'll see. That would be so.
Nearest degree.
Got it. Done.
No shouting out.
I think I got it right.
Right?
You'll find out, Ryan.
You're trying to find the measure of angle C?
What? You're saying. Oh.
I'm gonna get unorganized. Actually, I have not, but I checked too much stuff.
Did you get to the nearest degree? It's 29 degrees?
Yes, you're wrong, and you're wrong. Eat it. Sorry, I had to do it because they tried to prove you wrong.
No, I didn't. I asked.
All right. Tonight's homework, guys, is practice with basic problems. Now, part of this homework is page 211 out of your workbook and page 215. And here's the homework. Part of it is where it tries to combine what we already know about special right triangles with what we talked about today and yesterday about right triangle trig. So let's take a look at how they could give us that combo. We know that with a 30, 60, 90, it's x, 2x, x root 3. So the ratio will always simplify to this, won't it? 1, 2, and the square root of 3. No matter what these are, x to 2x simplifies 1 to 2. It always simplifies to 1, 2, square root of 3. So if I ask you for sine of 30 without a calculator, which I could do, you ought to be able to draw this special right triangle and go, okay, 30's here, so the short leg is x, which we can represent with 1. The hypotenuse is 2x, which we can represent by a 2. And the long leg is x times the square root of 3. Well, 1 times the square root of 3 is just 3. So what would sine of 30 be? Opposite over hypotenuse, 1/2. I ought to be able to ask you for cosine of 45 because this is x root 2. So it would always reduce to 1 times the square root of 2. So cosine of 45 would be adjacent over hypotenuse, 1 over the square root of 2. Can I leave it like that? No.
Square root of 2 over 2.
Square root of 2 over 2. Now, you know 2 reasons why sine would be the same. We know that they are complements of one another, so they better be the same. See, they're complements, right? 45 and 45, aren't those complements? They better be the same, and I can look at the triangle and tell they're the same. Okay, so that's part of the problems on this page are just kind of a combination. What did I know before with what do I know now? All right, so there's your homework. Take it to IF. Do it in IF instead of between 5th and 6th period tomorrow. That's right. That's right.